Assalamu alaikum. So voltage is simply the work done or the energy transferred, per unit of electrical charge for it to go from one point in the circuit to another, right? And we know that there are two types of voltage. We have the potential difference, which we've seen already. So potential difference is simply the voltage across, so potential difference is simply the voltage that goes across a part of the circuit. So either a single component or a number of components. So that's the voltage or the potential difference across a set of components, but not the entire circuit, right? Whereas the other type of voltage is the electromotive force. It's called the electromotive force, right? So electromotive force. So the difference between the two is that potential difference is only for a part of the circuit, so perhaps a resistor or a combination of resistors or bulbs, etc. However, the electromotive force is the work done or the energy that's transferred per unit of charge, so per coulomb of charge, for it to go across the entire circuit, precisely one time, right? So that's the difference between the two terms. So the formula to determine voltage remains the same. The formula to determine voltage is equal to work done, voltage in volts, right? And work done, which is the energy that's transferred in joules per unit of charge, and charges are measured in coulombs. So the only two sources of electrical energy when it comes to DC or direct current circuits is either the cell or the battery, and a battery is simply a collection of cells that are connected and working together, right? So how does a cell even work? So a cell is simply a device that has chemical stored potential energy, right? So chemical, remember how we said that stored energy is known as potential energy? So chemicals, potential energy. And what happens is basically a number of reactions are made to take place within the battery or the cell, so that an excess of electrons develops at one of the terminals of the cell, and a deficiency of electrons is created at the other terminal, right? So the terminal that has the excess of electrons is said to be negatively charged, and the terminal that has the deficiency of electrons is said to be positively charged, or it's said to be the positive terminal of the cell or the battery, right? So that's the positive terminal, this is the negative terminal, and with that difference in potential energy, you can see that difference in the number of electrons, right? So that difference in the number of electrons is basically the source of the electron flow. So electrons are made to flow coming out from where there's an excess of electrons moving around the circuit and coming back to where there is a deficiency of electrons, right? So all of this is made to happen due to that thing that we discussed earlier on, which is potential difference. So there's a difference in potential. The positive terminal is said to be at a greater potential, right? And the negative terminal is said to be at a lesser or smaller potential. And the potential difference between the two ends are basically what cause the electrical current, which is a form of kinetic energy, right? So that's the electrical energy to flow around the circuit. And the total voltage, the total potential difference, the total energy that is there per charge, meaning the voltage, the work done, the energy that is available per unit of charge, is basically the electromotive force in this case, because that is the energy that's going to be consumed when the charges move throughout the circuit, right? So the energy that is going to be consumed by the remaining circuit is known as the electromotive force. Now, cells aren't perfect conductors of electrical current themselves either. I mean, we know that the cells are the drivers of electrical current, but even they themselves aren't perfect conductors. So what happens is that some of the chemical energy that is converted into electrical energy, so some of the electromotive force or some of that work done per coulomb of charge is consumed. Some of that energy is consumed just to push electrons from one end of the terminal across to the other end, right? So from the positive to the negative end. So when some of the energy is consumed there, we say that it occurs due to something known as an internal resistance. So internal resistance, which is simply the opposition of the internal structure of the cell to the free flow of electrical current. So what happens is some voltage is consumed out of that electromotive force. So electromotive force, the total chemical energy that is converted into electrical energy, some of it is consumed to get across the internal resistance. We just call it V internal, right? So the voltage consumed in getting across that internal resistance of the cell itself, and the remaining voltage, the remaining energy per coulomb is available to the rest of the circuit, so we'll just call it the potential difference, right? So the remaining voltage is basically the energy per coulomb that is consumed by the rest of the circuit to move the charges across it, right? So that's something to remember. If you have gone through the video on Ohm's law already, you can write this voltage as the current. In series, current is going to be constant, so you don't have to be specific in that case, times the internal resistance of the cell itself. So electromotive force becomes the current times the internal resistance, so the internal, the energy consumed in pushing electrons from one end or one terminal of the cell to the other end. So that voltage plus the voltage that is consumed by the rest of the circuit, the potential difference by the rest of the circuit. So that's what happens in a cell. So let's try and add some voltage. The cell is supplying 6 joules of energy to each coulomb of charge as it goes from the positive terminal through to the negative terminal, and that is what is driving all of the cells across the remaining part of the circuit. So internal resistance within the cell, some of the voltage is consumed by the cell itself, and the remaining bit is going to be consumed, the potential difference is going to be consumed by the remaining part of the circuit. So that's it for this video. Be sure to go through the outcomes in the description below, and take care.